Are you ready to discover the hidden danger lurking in space? Join us as we explore the impact of space debris on satellites and space missions, a threat that could jeopardize our ability to explore the cosmos. Don't miss out on this eye-opening video about how space junk can impact you. Without further ado, let's get back to the video. Since the beginning of the space age in 1957, tons of rockets, spacecraft, and instruments have been launched into space. Initially, there was no plan for what to do with them at the end of their lives. Since then, numbers have continued to increase, and explosions and collisions in space have created hundreds of thousands of shards of dangerous debris. The biggest contributor to the current space debris problem is explosions in orbit, caused by leftover energy, fuel, and batteries onboard spacecraft and rockets. Despite measures being in place for years to prevent this, we see no decline in the number of such events. Trends towards end-of-mission disposal are improving, but at a slow pace, explains Holger Krag, head of the Space Safety Program. Space junk is classified by NASA according to whether it is of natural or artificial origin, with the latter defined as any man-made object in orbit around the Earth, which no longer serves a useful function. But how does space junk affect the environment and us? The accumulation of space junk poses a particularly catastrophic threat to humankind's future in space exploration, due to the increased risk of collision with and damage to functioning satellites. It could also have detrimental effects on Earth's environment. What is space junk? Artificial or orbital, space junk consists of objects ranging from paint flecks from functioning space stations to those as large as decades-old inoperative spacecraft. As of August 2021, the European Space Agency, ESA, reports that approximately 29,210 pieces of debris are tracked regularly by space surveillance networks. Statistically, however, the numbers are likely to be much higher. The count of artificial objects in orbit around the Earth that are greater than 10 centimeters in length is likely to be approximately 34,000. with approximately 900,000 objects between 1 centimeter and 10 centimeters. For those objects between 1 millimeter and 1 centimeter, the count is 128 million. Consequently, the sheer number of these objects currently in orbit, and their potential to slam into other objects at speeds of up to 5 miles per second, means that the risk of causing serious damage to functioning spacecraft is significant. In 2006, the International Space Station's ISS fused silica and borosilicate glass fortified window suffered a 7 millimeter chip due to an impact from a piece of space debris no larger than thousandths of a millimeter across. It is easy to see the threat posed by much larger objects. A single collision can generate thousands of particles of space trash. In 2009, the inactive Russian satellite Cosmos 2251 collided with the active American communication satellite Iridium 33 approximately 804 kilometers above Siberia, resulting in approximately 2,000 pieces of debris, at least 10 centimeters in diameter, and thousands of smaller pieces entering the Earth's atmosphere. It is estimated that over 50% of the debris from Iridium 33 will remain in orbit for at least a century, and that of Cosmos 2251 for at least 20 to 30 years. Space pollution effects and impact of space debris. Effect on satellite. Debris can also be caused by an explosion in space or when countries conduct missile tests to destroy their satellites by missiles. Apart from Russia, China, the United States, and India have shot down satellites, creating space debris. As space debris orbits around the Earth at tremendous speeds, about 15,700 miles per hour, 25,265 kilometers per hour in low Earth orbit, it could cause significant damage to a satellite or a spacecraft in case of a collision. Every satellite that goes into orbit has the potential of becoming space debris. Professor Hugh Lewis, head of the Astronautics Research Group at the University of Southampton, said in an interview, "With the launch of more satellites from companies such as Elon Musk's Starlink and OneWeb satellite constellation, near-Earth space will likely see more space debris. This includes items such as spent rocket stages, defunct satellites, and other debris generated by human activities in space. The impact of space debris on satellites can be significant, as these objects can collide with functioning spacecraft and cause serious damage. This can include the destruction of critical components, such as solar panels, or damage to sensitive equipment like sensors or antennas. In extreme cases, a collision with space debris can result in the complete loss of a satellite. The threat of space debris is particularly acute in low Earth orbit, where the density of debris is highest. Satellites in this region must constantly maneuver to avoid collisions, which can be both time-consuming and costly. As the amount of space debris continues to increase, the risk of collisions will only grow, making it critical that steps are taken to mitigate the impact of space debris on satellites. These measures may include the development of new technologies for debris removal or the implementation of better tracking and avoidance systems for active satellites. The impact of space debris on space machines. The impact of space debris on space missions is a significant concern in the modern era of space exploration. Space debris is composed of various materials such as metal fragments, spent rocket stages, defunct satellites, and other man-made objects that orbit the Earth. This debris can travel at very high speeds, and a collision with any of these objects can have catastrophic consequences for space missions. The debris can cause damage to spacecraft and satellites, which can lead to the failure of the mission or even endanger human lives. The impact of space debris can also generate more debris, which can increase the risk of future collisions. NASA and other space agencies have developed protocols to track and monitor the movement of space debris to prevent collisions. They also use advanced technologies to shield spacecraft and satellites from debris. The impact of space debris on space missions highlights the need for responsible space practices that aim to reduce the creation of debris and the risk of collisions. Overall, the impact of space debris on space missions is a critical issue that requires continued attention and research to ensure the safety and success of space exploration. In conclusion, as we continue to push the boundaries of space exploration, the impact of space debris on satellites and space missions cannot be ignored. The implications of debris collisions could be catastrophic, and the potential risks are simply too great to ignore. If you love this video, kindly subscribe to our channel so you won't miss out on our videos.